Okay, so in this 2010 question, we've been given two spheres, let's call them A and B. They're both moving in the question, and we've been given the resolved versions of their velocities, 6i plus 2j and 2i plus 4j. They collide where the I-axis is along the line of centers, which means that only the I components of their velocities will change. The j components will remain the same. So we're going to write down the velocity of A before the collision, which is 6i plus 2j. That's been given to us in the question. And then after the collision, as we said, its I component is going to change. So let's call it V1, an unknown variable. And then the j component is going to remain the same as it was before the collision, which is 2j. Likewise with sphere B, which is of a different mass. The mass of sphere A is m, and the mass of sphere B is km. Its velocity before the collision is 2i plus 4j. Again, that's been given to us in the question. And afterwards, only the I component will change. Let's call it V2, an unknown variable. And then plus 4j, the j component remains the same. So that's just important work to do at the start. And now as we launch into the PCM and the NEL, we're going to only take them in the I direction. So it's going to have 6 as U1. V1 is obviously just V1. 2 is U2. And then V2 is going to be just V2. And then M1, the mass of the first sphere, is M, and M2, the mass of the second sphere, is Km. So we'll plug those into both our PCM and then our NEL. So the PCM, first of all, is M1U1 plus M2U2 equals M1V1 plus M2V2. So plugging in the numbers we have, it's M times 6 plus Km times 2 equals M times V1 plus Km times V2. We can cancel all of the m's, or divide every term by m, and we're left with our first equation, which is v1 plus kv2 is equal to 6 plus 2k, and we'll just label this equation 1. The NEL then, we have v1 minus v2 equals minus e on u1 minus u2. Again, plugging in the speeds that we know, we have v1 minus v2 equals minus e on the speed of the first sphere before the collision, which is 6, minus the speed of the second sphere before the first collision, which is 2. And again, these are speeds in the I direction only. So our second equation then is v1 minus v2 equals minus 4e. So we label that equation 2, and we launch into our simultaneous equation. So I'm going to leave the first equation as it is. So we have v1 plus kv2 is 6 plus 2k. And then I'm going to multiply equation 2 by minus 1 so that I can cancel the v1s. So I'll draw a line underneath, cancel the v1s. kv2 plus v2 is just kv2 plus v2, or we can factorize that and say that it's v2 on k plus 1, and then that's equal to 6 plus 2k plus 4e. We'll divide both sides by k plus 1 to get v2 on its own, so v2 is k plus 2k plus 4e all over k plus 1, and that's the I component of the velocity of B after the first collision. To find the I component of the velocity of A after the first collision, we could either sub this back into either equation 1 or 2, or just restart the simultaneous equation, which is what I'm going to do. So I'm going to write down equation 1 again, and then for equation 2, so that I can cancel the v2s, I'm going to multiply each term in equation 2 by k. I'm going to draw a line underneath, I'm going to cancel the kv2s, and then adding down the rest, I have v1 plus kv1, or I can factorize the v1 and just say v1 on 1 plus k is equal to 6 plus 2k minus 4ek. Divide both sides by k plus 1, and we get the velocity in the I direction of sphere A as 6 plus 2k minus 4ek over k plus 1. Now it's a good idea just to write both velocities afterwards, just before we go and do the next part of the question, including these v1 and v2, and we'll just do that on the next page. So here's our velocities after the collision. The velocity of A has a new I component, that was the v1 that we just found, and it remains, or keeps, the j component that it had. And likewise, velocity of B after the first collision has a new I component, that was the v2 that we just found, and it keeps its j component, which was 4. Now we're told that the slopes are parallel after the collision, or that they move in parallel directions. So if we have a look at the sketch up here, we can see it looks something like this, that the two spheres have collided and now they're moving parallel to each other. And if two spheres are moving parallel to each other after the collision, it means that their slopes are the same, or the angle or the direction of motion is the same. And how do we find that direction of motion or slope? Well, we have a little formula that says that the tan of the angle is equal to the j component over the I component, or if we think of trigonometry, the opposite side over the adjacent side. Where are we going to get this opposite and adjacent side? Well, there are these vectors here, where the j component is obviously the opposite, so that's 2, and the I component is the adjacent, which is 6 plus 2k minus 4ek over k plus 1. So I'm going to let these equal to each other. So the j component, 2, over the new velocity of the I component of sphere A is going to be equal to the j component, 4, over the v2, which is the new velocity of the I component of sphere B. Plug in v1 and v2. We can divide both sides by k plus 1 to cancel that. And then we can cross multiply to have 2 on 6 plus 2k plus 4e equals 4 on 6 plus 2k minus 4ek. And multiply all this out and we get 12 plus 4k plus 8e equals 24 plus 8k minus 16ek. We're looking to find e in terms of k, so keep anything with an e in it on the left hand side. So 8e and then plus 16ek on the left equals 24 plus 8k minus 4k minus 12. Tidying up both sides, we'll factorize the e on the left hand side, so we have e on 16k plus 8 equals 24 minus 12, which is 12, and 8k minus 4k, which is 4k, and then we'll divide both sides by 16k plus 8 to give us that e is equal to 12 plus 4k over 8 plus 16k. I can see that 4 will divide into all of these terms, and so I'll divide above and below the fraction by 4, and we get e is equal to 3 plus k over 2 plus 4k, and that's the answer to part 1. So for part 2, we're trying to prove that k is greater than or equal to 1 over 3. So we found a value for e. E is 3 plus k over 2 plus 4k, and we know that e has to be less than or equal to 1. So if we let e less than or equal to 1 and replace e with our 3 plus k over 2 plus 4k, we have a simple linear inequality. We're going to multiply both sides by 2 plus 4k to give us 3 plus k is less than or equal to 2 plus 4k. So collecting the k terms on the right, I have 4k minus k, which is 3k, and number terms on the left, I have 3 minus 2, which is 1, and then divide both sides by 3, and that gives us 1/3 is less than or equal to k, or the other way of saying that is k is greater than or equal to 1/3, which is what we were required to show. And just one small point, we were allowed to multiply both sides by 2 plus 4k because we knew that k was a positive number. K was part of the mass of the first or the second sphere, sphere B, and so we knew it was a positive number. If it had been a negative term, we would have to change the sign of the inequality. If it was a term that we didn't know whether it was positive or negative, we'd have to have multiplied both sides by 2 plus 4k squared, and so we'd have a rational inequality then that we'd have to try and solve.